What if I told you that ancient Cambodian temples hid technology resembling Tesla coils? Shocking evidence reveals that Angkor Wat structures utilized wireless energy similar to Tesla coil technology thousands of years before its modern invention. In this special investigation, we'll uncover the mysterious carvings that prove this lost technology, scientific tests confirming strange electromagnetic fields, impossible engineering designs that baffled experts for decades, the shocking truth behind the disappearance of this advanced technology. Watch the evidence that will change your understanding of history forever.
This is Angkor Wat, a vast stone temple complex in the jungles of Cambodia. Built in the early 12th century, it stands as a testament to the ingenuity and vision of the Khmer Empire. Scholars have studied its spires, galleries, and courtyards for decades. Yet there are some secrets carved into the very stone itself that continue to baffle even the most experienced archaeologists. Look closely, and you'll notice details, hundreds of meters of intricate bas-reliefs featuring warriors, mythical beasts, and celestial figures. But mixed among these, there are a handful of oddities. Hidden away in dimly lit corridors and often overlooked, some of the carvings depict shapes and symbols that seem out of place for the era. High-resolution images reveal one of these enigmas: a circular motif, segmented, with coils and what appears to be filaments or wires. Nearby, another carving shows what looks like a socket or connector, its lines perfectly straight and its configuration reminiscent of modern circuitry. The shapes are subtle, so easily mistaken for another example of ancient artistic flourishes. But for some observers, these don't look like religious symbolism at all. They resemble the schematics of electrical components. For example, compare this stone engraving at Angkor Wat with original sketches from Nikola Tesla, the 19th century inventor known for his pioneering work in electromagnetism. Tesla's diagrams for inductors and transformers show swirling coils, orderly lines, and symmetrical patterns astonishingly similar to the motifs carved in Cambodia nearly 7 centuries before Tesla was even born. Are these just a coincidence? The popular theory among mainstream archaeology is that these carvings are rooted in the spiritual and cosmological beliefs of the Khmer. The coils and lines could represent sacred snakes, naga, or symbolic mandalas employed in Hindu cosmology. Yet that explanation doesn't satisfy everyone. Across internet forums and late-night documentaries, some claim these are evidence of long-lost technology or even knowledge passed down from an ancient advanced civilization. Others point to the extreme precision of the carvings, the clean geometry, and three-dimensional perspective as clues to a forgotten chapter in human history. But when placed side by side, Tesla's hand-drawn diagrams and the stonework of Angkor Wat do indeed show striking visual echoes. Side-by-side comparisons heighten the intrigue. Was there more to these carvings than meets the eye? Perhaps the artists behind Angkor Wat drew inspiration solely from the natural world, their motifs coincidentally mirroring shapes found in modern electrical engineering. Or maybe these enigmatic symbols are a reminder that human creativity has always chased after the same elusive mysteries, from the spiritual to the scientific, leaving behind puzzles for future generations to decipher. The true meaning remains etched in stone, awaiting the next observer, willing to look a little closer. Electromagnetic fields are everywhere, from the wireless signals that connect our devices to the power lines weaving through our cities. But how do we truly know what levels of electromagnetic fields are present in our environment? And how do engineers and physicists measure and interpret these fields? Let's start with the basics of on-site electromagnetic field testing. Instead of relying on simulations or theoretical models, real-world measurements use calibrated instruments like spectrum analyzers and electromagnetic field meters to record the strength and frequency of fields right where we live or work. A typical field test might involve placing sensors at various heights and distances from sources like cell towers, Wi-Fi routers, or high-voltage lines. Measurements are taken in microteslas or milligauss for magnetic fields and volts per meter for electric fields. But the data by itself doesn't mean much unless it's interpreted by experts. I reached out to several professionals in engineering and physics for their insights. Dr. Leila Hassan, an electrical engineer, emphasized the rigor required. Accurate field assessment means accounting for not just peak values, but fluctuations over time and their proximity to human activity. The placement of your measurement equipment, whether it's 1 meter from a wall or 10 meters from a power line, significantly affects readings. Meanwhile, Physicist Dr. Sami al-Rashid highlighted the influence of building architecture. Materials like reinforced concrete, steel, and even window coatings can dramatically shield or amplify electromagnetic signals. Field tests have to trace inside and outside environments to capture the whole picture. These expert opinions reveal just how complex and variable real-world exposure can be. What about the evidence from scientific reports? A 2020 meta-analysis published in the Journal of Environmental Engineering reviewed over 50 in situ electromagnetic field studies. The key conclusion: in most urban and residential areas, field levels fall far below internationally recognized safety limits, such as those set by the International Commission on Non-Ionizing Radiation Protection. However, the same reports caution about specific hotspots. For example, direct proximity to transformer stations or standing for long periods under high-voltage power lines can produce exposures approaching recommended limits. These findings echo advice from national health agencies: minimize unnecessary exposure where possible, but understand that most everyday situations carry negligible risk. The convergence of precise on-site measurements, expert interpretation, and documented scientific reports paints a reassuring but nuanced picture. With proper monitoring and adherence to safety standards, electromagnetic fields in our environment can be managed safely and transparently. Imagine, for a moment, that somewhere in the deep past, an advanced civilization found a way to transmit energy or information wirelessly through the air. Intriguing as it sounds, this hypothesis has captivated researchers for decades. What if ancient people really did tap into a technology that we've only just begun to understand? Let's set the stage. Ruins across the world, from Egypt to South America, feature enigmatic stone structures whose purpose isn't fully understood. Some theorists suggest that these buildings aren't just monuments, but part of a lost technological network, possibly transferring energy or even communicating across vast distances, all without visible wires or cables. Fast forward to our own era. Today, wireless technologies are everywhere. Think of Wi-Fi, Bluetooth, and even wireless power transfer, like the way you can charge a smartphone just by placing it on a specialized pad. These modern marvels rely on sophisticated principles of electromagnetic induction and resonance, transmitting signals and power invisibly through the air. Could the ancients have understood something similar, hidden within the stone and metal of their constructions? Let's dig a little deeper into the materials. Ancient masonry often includes elements like granite, basalt, and limestone. These stones have intriguing properties. Granite, for instance, contains traces of quartz, a natural piezoelectric material that can generate an electric charge under mechanical stress. Some ancient builders also embedded copper and other metals into their structures, leading some to speculate about their purpose beyond mere decoration or structural strength. In modern wireless power transfer, conductive materials are arranged in precise patterns: coils, resonators, or antennae. When energized, these elements manipulate electromagnetic fields, allowing energy to jump between devices without touching. Could carefully placed stone blocks and metallic inclusions in ancient architecture have served a similar, albeit rudimentary, function? Of course, therein lies the most tantalizing question. While there's no definitive proof that ancient people created true wireless energy networks, the comparisons with today's technology are hard to ignore. The great halls of Egypt's temples, with their high ceilings and oddly shaped chambers, sometimes lined with faint traces of metal, invite us to wonder, were these the prototypes of resonant halls, amplifying and transmitting subtle energy currents? Ultimately, the mystery endures. Modern scientists continue to analyze the properties of ancient materials and the arrangement of archaic structures, searching for echoes of forgotten technologies. Whether serendipity or insight fueled these ancient inventions, we may never fully know. But perhaps, in unraveling these parallels, we're not just glimpsing the past, we're rediscovering new possibilities for the future. Throughout history, there have been countless tales of lost civilizations, societies that appear to have possessed knowledge far beyond what we knew possible for their time, only for that knowledge to suddenly vanish. This is the heart of what some call or the disappearance theory, an attempt to explain why advanced bodies of knowledge, technologies, or even entire sciences seem to have abruptly disappeared from the historical record. Today, we explore this theory. Why did this advanced knowledge simply disappear? Is there any clear reason, or is the answer more complex and perhaps more troubling than we expect? One of the first explanations offered links the disappearance of advanced knowledge to natural disasters. Throughout history, Catastrophic events, volcanoes, earthquakes, floods, and even celestial impacts have swept away entire communities overnight. Consider the eruption of Mount Vesuvius, for example, which buried the city of Pompeii and its libraries under meters of ash. Or the legendary flooding of the Black Sea, which may have submerged early centers of civilization. It's not hard to imagine that in such chaos, knowledge painstakingly built over generations could be lost just as quickly. Documents burned, teachers scattered, oral traditions silenced, nature itself can wipe entire chapters from humanity's memory. But natural disasters are just one possibility. The disappearance of knowledge is also intimately tied to human history: wars, invasions, and political upheavals. The burning of the Library of Alexandria remains perhaps the most iconic example, a repository of learning, destroyed in a storm of conquest and confusion. During the Mongol invasions, the great libraries of Baghdad were cast into the river Tigris. Reports claim the waters ran black with ink. In these cases, historical events operated with the same destructive force as any earthquake, scattering both people and the wisdom they carried. There is, however, a darker possibility. What if, at times, this knowledge was not just lost but deliberately erased? Throughout history, those in power have always understood that controlling information is a means to shape the future. In China, the infamous burning of books and burying of scholars under the Qin dynasty sought to unify thought by destroying dissenting knowledge. In Europe, waves of religious reformation and counter-reformation led to mass book burnings and censorship. In these events, the destruction was not the result of accident or disaster, but careful, intentional purging or rewriting of what people would remember. Evidence of such deliberate erasure comes to us in many forms: gaps in historical records, sudden breaks in technological continuity, or objects whose existence doesn't fit the conventional timeline. Sometimes, even the act of forgetting leaves its own subtle fingerprint, a palimpsest where traces of what was erased can still be glimpsed under the surface. So, why did this advanced knowledge disappear? It may have been snuffed out by fire, drowned by flood, or erased by the hand of authority. What remains clear is this: our past is not just defined by what survived, but equally by what was lost, and the story of that disappearance is a powerful reminder of both our potential and our vulnerability. The question remains open, inviting us to search, to question, and perhaps, one day, to rediscover what was once forgotten. The possibility that ancient civilizations possess technology more advanced than we previously believed has the power to fundamentally reshape our understanding of history. If new evidence suggests that tools, methods, or even forgotten sciences existed thousands of years ago, tools that rival or surpass what we once considered possible, then our entire narrative of human development shifts. No longer are ancient peoples simply the primitive architects of stone and bronze. They become innovators whose achievements we may have underestimated for centuries. This reimagining of history isn't just academic. For instance, the discovery of surprisingly complex mechanisms, like the Antikythera device from ancient Greece, forces historians to question what else might have existed. Did civilizations like Egypt, Mesopotamia, or the Maya harness forms of energy, mathematics, or engineering knowledge that were lost to time? Such questions invite us to look at the ruins and the artifacts with new eyes, searching for clues that have eluded generations. Imagine if modern techniques, from advanced imaging to AI-driven analyses, were applied systematically to ancient sites. We could uncover patterns in construction, material use, or even alignments with astronomical bodies that hint at a level of technological planning far ahead of their era. If ancient engineers were capable of moving massive stones with precision or mapping the stars to within fractions of a degree, what does that reveal about the lost chapters of human knowledge? Today, the practical applications of reevaluating ancient technologies are vast. Modern architects and engineers are already studying ancient materials science, like Roman concrete, for inspiration. By understanding how ancient societies built cities that still stand, provided water across deserts, or encoded knowledge in enduring ways, we can develop new, sustainable solutions for contemporary challenges. There's a growing movement to blend ancient wisdom with modern technology, adapting, for example, the passive cooling techniques used in Middle Eastern architecture or the natural fertilizers applied in the Amazon basin. So, let's summarize the three most shocking points. First, discoveries of ancient devices challenge our timeline of technological progress. Second, applying new analytical techniques to ancient sites could completely rewrite what we know about our history. And third, Lessons from the past are directly influencing innovations in today's world, from construction to climate solutions. But here's the big question. Do you think ancient civilizations really had advanced technology that we've overlooked or forgotten? What evidence convinces you one way or the other? If this topic fascinates you, make sure to subscribe to the channel and hit the bell icon so you don't miss any of our future explorations into the mysteries of history.